Good morning students, welcome back to your chemistry class. So today we are going to do the nomenclature of the coordinate compound. So I'm going to write down the rules also, and with the example also I will explain you. So you also take out your registers and get started and write down all these rules so that it becomes easy for you to understand. Okay, rules of nomenclature. So coming to the first point, what? Order of naming the ions, right? Like for example, in NaCl, how do we name it? It is first we use the positive sign, then we use the negative charge, isn't it? Therefore, in the same manner, in the coordinate compounds, they can also be written as like this. See, this is either plus the entity inside and this is your anion, or it can also be written as plus and this becomes your minus. Okay, so these are the two different ways how the coordination compounds can be written. Second point, naming the coordination entity, right? So first, since the compound is written like this, okay, so first we talk about ligands and then we talk about the central metal atom, right? First we talk about ligands and then we talk about the metals. Third point, naming the ligands. How do we name the ligands? Naming the ligands. This is very important. If you do not know this, then it will be very difficult for you to write down the names of the coordination compound. So you have to learn these as well. So I'm giving you some list of certain ligands over here which are very common and often used in the formulas. So you can mention it like F1. This is fluoride, but we do not write as fluoride. What do we call it as? Florido. Okay. Similarly, chlorine is called as chlorido. Then NO2. Do you remember anything about NO2? This is nitrito. Okay. N. Then ONO. What is this? Nitrito O. These two are the, if you remember, ambient ligands. Okay, they coordinate through more than one sides. Okay, then azide, that is N31. What is this written as? This is called as azido. Okay, then CO3 2 minus, this is carbonate. This is, therefore over here it will be called as carbonato. Okay, then cyanide, it will be called as cyanido, or it can also be called as cyano. Okay, so over here what you have to remember, all the 8 ite and ides, they all change to the last alphabet becomes O, that is 8 change to ato. Okay, then ite changes to ito and ide also changes to ido. This is what you have to remember. So these are some of the negative or the anionic ligands. What are these? I did not write down over here. These are anionic ligands. Okay, do remember, this is very, very important. Right, now I'm writing over here some neutral ligands. Some neutral ligands could be, for example, CH3 NH2. What do we call this as? This is methylamine. It is a neutral ligand. Okay. Then CO. What is this called as? Carbonyl. Then CS. This can be called as thiocarbonyl. Then another one could be which one should I give you? Okay, yes, this one is very important. NH2, CH2, CH2, NH2. What is this? This is ethylene diamine. The name is ethylene diamine, which is generally written as EN. Followed? Are these clear? Then coming to some special names given like H2O. This is also neutral ligand, okay? And NH3. This is also a neutral ligand, but for special name is given to them. H2O is named as aqua, and NH3, it is written as amine. Okay, I hope these ligands you will remember. Okay, some examples of this if you want to know, then it could be like for example, okay, let me give you some examples of this. Cyanide. Okay, if it is cyanide, what will be the name then? It will become cyanito. Okay, if it is cyanide, then it will become cyanido, right? If it is cyanate, then what will it be called as? Cyanato. So this is what I wanted to tell you. 8 how they change to ato, ito and ido. So these are some negative ligands, these are some neutral ligands, and these are some neutral ligands which have special names, and how 8 has changed to ato, ito and ido, and here are certain examples of it. I hope till here things are clear. Then we move to the next part of the nomenclature. To the next point in the nomenclature, order of naming the ligands. Okay, order of naming the ligands. So if there is one ligand, then obviously one has to be written, but if there is more than one ligand, then they have to be named according to the alphabet. So I'm writing over here, if more than one ligand, then use alphabetical order. Okay, just now I'm going to give you example and explain you, things will be clear. Then fifth point in the rule of nomenclature that you need to remember, the prefixes have to be indicated. Numerical prefixes have to be indicated to the number of ligands. Okay, numerical prefixes to indicate number of ligands. So how do we write that? If there are two ligands, if two ligands are there, then we use the word bi. If there are three ligands, then we use the word tri. If there are four ligands, then we use the word tetra. If there are five ligands, we use the word penta. This point is clear. But if the ligand is already has these names of tri, tetra and penta, then in that case what are you going to do? Then in that case, if there are two ligands, okay, and the name already bi is written to over there, then we use the word bis. Okay, if there are three ligands, tri word is already used there, then we use the word tris. If there are 4 ligands and tetra word is already used there, then we use the word tetrakis. And if there are 5 ligands with penta word already been used there, then we use the word pentakis, and so on. Then coming to the 6th point over here, ending of the names. How do we end the names? So in anionic complexes, okay, I'm writing it down over here. In anionic complexes, the central metal atom, it always ends with 8. Always remember, very important point. The 6th point is very important. Okay, ending the name. In anionic complexes, the central metal atom always ends with the word what? 8. And in cationic complexes or even the neutral complexes, there is no change. We do not change the name. Okay, so let us understand this in this form. When I said anionic complex and cationic complex, so anionic complex is like this. Okay, this is X is plus, and then the entity inside, this is your central metal atom. Okay, and this is minus sign over here. So over here, then in this case, the central metal atom, it will be ending with the word 8. The central metal atom, it will end with the word 8. Okay, then in cationic complex, what is a cationic complex? This is your anionic complex, and I'm talking about cationic complex now. How do we see the cationic complex? This is your cationic complex. Then over here, no change takes place in the name. It has to be written as what is given in the question. Okay, now I'm going to give you examples and specify more as to how to name the anionic complexes and how to name the cationic complexes separately. Is that clear? So I shall first begin with maybe cationic complex or anionic complex. Let me see. First, let me rub this off. To begin with, okay, let me start with cationic complexes. Okay, so if the complex is positively charged, then only it will be called as cationic complex. Okay, that is, I'm talking about what? This plus X is minus. This is your cationic complex. Cationic complex. Okay, so over here, first write the number of ligands. Okay, I'm writing steps over here now, and accordingly you have to name. Write the number of ligands first, right? Say for example di, tri or tetra, whatever is given there. Then the second thing that you have to do, you have to write down the name of the ligand. First we need to write down the number of the ligand, and then we write down the name of the ligand. Write the name of the ligand now. Okay, then third point, if more than one ligand is there, then what do we write? If more than one ligand exists in the question, then what do? We write it down in the alphabetical order. So if more than one ligand exists, write in alphabetical order. Okay. Then after this, what should you do? You should write the name of the metal followed by the oxidation state of that central metal atom. Okay. Then write the name of the metal followed by the oxidation state of the central metal atom. And finally, what you have to do? Write down the name of the anion. Finally, write the name of the anion. So these are the 5 steps you have to take when you come across cationic complex. Now I'm going to give you the formula and we are going to name it. So let's take an example over here. It can be CrNH3 whole thrice. Then if I take this H2O whole thrice Cl3. Okay. Now look over here. This is plus and X minus. So what kind of a complex is this? This is a cationic complex. I hope this first point is very clear. If the complex is positively charged or it is a cationic complex. Now we are going to read every step and name this. Write the number of ligands. Now how many ligands are there over here? Right, 2 are ligands are there. Now look at the first ligand. It is 3 and over here also it is 3. Then what does it say? That if there are more than one ligand, then write down alphabetical. NH3, what is the name of NH3? NH3 is amine, isn't it? And what is H2O? This is aqua. Both start with A. Then see the next one, M or Q. M. So this will come first and this is going to come next. So first write down the number of ligands. How many ligands? Tri. So the name becomes triamine. We are writing down the name of the ligand. Then this is what? Aqua. Now I left the space. There should be no space in between. I left it purposely to show you. There should be no space in between the names. Do remember this. If you write it down like this, it goes wrong. They all have to be in one line. So I rub this off and I write it down like this. Triaqua. So triamine, triaqua. Write the name of the ligand. Write the name of this ligand in the alphabetical order. Now we come to the 4th point. Then write the names of the metal followed by the oxidation number. Now what is the metal over here? Chromium is the metal. So I write down chromium. Now what is the oxidation state followed by oxidation state? What is the oxidation state of chromium? How do we find out the oxidation state of chromium? 0, 0, minus 1 into 3. So X will be equal to how much? 3. And this oxidation state has to be written in Roman form. Okay, in the Roman number. Lastly, finally, write down the name of the anion. What is the anion? Chlorine. So it has to be written as what? Chloride. You don't write it chlorine. It is chloride. So this is the name of this particular compound. What is the name? Triamine triaqua chromium 3-chloride. I hope all the steps are very clear for cationic complex. This is how we write down the name. Now coming to the negatively charged complex or the anionic complex. And we come to if complex is negatively charged. Okay, so negatively charged, I am talking about anionic complex. Okay, so how do we see the anionic complex? How do we recognize the anionic complex? It is X plus, and inside the bracket it has to be minus, then it will be an anionic complex. So first I'll write down the steps and then I'll give you an example as I did it previously. So what do we do now? Steps are absolutely different for an anionic complex than if you compare it with the cationic complex. Okay, so over here, first name the cation, okay, without any number, without number. Okay, second point, write the number of ligands, that is your di, tri and so on. Then you have to name the ligand, name the ligand. So what is the difference till now that you have understood with the positively charged complex? There we first write down the number of ligands, name the ligand alphabetically, but here in negatively charged complex we first write down the name of the cation and then we write down the name of the ligand along with di and tri. Then fourth point, if more ligands are there, what has to be done? Alphabetical order. If more than one ligand, follow alphabetical order. Okay, then the fifth point, as the complex size ion is anion, then the metal atom, it will always end with what suffix? Ate, A-T-E. Okay, followed by the oxidation state. So as the complex ion is an anion, the metal atom, it ends with what? With suffix ate. Okay, then followed by the oxidation state. Now let's take an example over here. Let's take an example like K4 FeCN6 for minus. Right? Now compare this plus, then the bracket with minus sign. So this is an indication that it is a anionic complex. I hope this is clear. Now let us name it. So first write down the name of the cation without using number. Don't say tetra or anything, without any number. Just name the cation. So what is the name of the cation? Potassium. Next, write down the number of ligands. What are the number of ligands? Hexa. So over here, hexa. What is it? Cyano. So cyano we write down. Then name the ligand, and if there is more than one, then alphabetical order. Here I have given you just one, so only one. Now the fifth point, as the complex ion is an anion, the metal atom will end up with the suffix ate. So what is the metal atom over here? Central metal atom is ferrum. It has to end up with ate. So what do we write over here? Ferrate. Then followed by the oxidation state. Let us find out the oxidation state of this. This is X minus 6. Okay. Plus 4. This will be equal to 6 minus 4. That will be how much? 2. So over here, Roman number 2. Okay. So this is the name of this particular compound. What is this? Potassium this is potassium hexacyanoferrate 2. Here we find out the oxidation state. Okay, then coming to the third type, that is IUPAC for bridging elements. Third category of classification, IUPAC for bridging elements. Okay, now understand, if you get something like this is a metal atom, then what do we write? We write down mu chloro. Okay, this is chloro. Then if you get it like this is the central metal atom, then we write down mu oxo. If you get OH and here you have the central metal atom, then this is how much? Mu 3 hydroxo. Clear? Let's take an example. I'll give you a example over here. NH3,4CO, NH2OH, CO, NH3,4, NO3, 4. Now name this compound. So follow as we have already been doing. Now firstly we write down the ligand over here. This is plus, this is minus. So what kind of a compound is this? First and foremost you let me know. This is cationic, but it has a bridging elements inside. The ligands are bridged. So we follow the same rule of the cationic complex. So here this is tetramine over here. So the name goes like tetramine. Cobalt is next. So cobalt. So how next we have to write down the oxidation state of cobalt. So how do we write down how do we find out the oxidation state of cobalt? There are 2 cobalt, so 2x. Okay, then this and this is 0, so plus 0, plus this is -1, this is -1, -1 plus -1 plus what next? This one, the valency of nitrate is -1 into how much? 4. Solve this. How much do you get? 2x, all this is equal to 0. 2x minus 2 minus 4 is equal to 0. So 2x is equal to 4, 5, 6, x is equal to 3. Clear? So here we write down Roman number 3. Now look at this. When do we write? When there is bridging over here. There is bridging, you can see. So next we write down mu amido, mu hydroxo. Then what do we have? Tetramine, then we write down the name of this, cobalt, 3. What is this? Nitrate. This is the name of the compound. So tetramine, this is the tetramine. Okay, cobalt, the oxidation state is 3. Then here we see the bridging element, so we write down mu amido, mu hydroxo. Fine. Tetramine, cobalt, again the oxidation state is 3, nitrate. So this is the name of the compound. I hope this is very clear to you. Now next I am going to tell you how to write down the formula from IUPAC names. Next topic is to write the formula from IUPAC names. Okay. So over here, what do we do first? First, the central metal atom is listed. Okay, is listed first. Second point, ligands have to be first seen, and that too how? Alphabetically, right? Third point, what you have to see? The polyatomic ligand formula. Then also remember that there should be no space between the central metal atom and the ligands. Clear? Fifth point that we need to remember, that for compound entities to be enclosed inside a square bracket. Compound entities enclosed in the square bracket. And last point, the charge over the compound to be written where? Written on right top side. Clear? It is something like this, 3 minus or whatever. I hope all these points are very clear to you. The seventh point is that the charge of the cation is then balanced by the charge of the anions. Okay, so these were some of the steps to write down the formula if an IUPAC name is given to you. Just now what were we doing? We were given the formula and we were writing down the IUPAC names. Now here the IUPAC name will be given to you and you have to write down the formula. So these are the steps that you have to follow. What? That the central metal atom is listed first, then the ligands have to be arranged alphabetically, then polyatomic ligand formula has to be used, no space has to be there between the central metal atom and the ligands, and the compound entities, they have to be enclosed inside the square bracket, then the charge where it has to be written right hand side top, and then finally the charge of the cation is balanced with the charge of the anion. Now coming to examples. Take certain examples over here. Example 1. Tetramine aqua chlorido cobalt 3 chloride. Okay. Now firstly try to judge what kind of a complex compound this is. This is your plus X minus. This is your cationic complex. Now as I had given to you the different steps, what has to be done first? Write down the name of the central atom. So what is the central atom over here? Cobalt, isn't it? So CO, it has to be written inside the bracket. Then what does it say? Tetramine aqua. Tetramine means amine is how many? Tetra, 4. NH3, 4. Aqua is how much? 1. Because there is no tri or bi is written. Then chlorido. If it is chlorido, that means do means inside the square bracket, that is Cl. Then the cobalt is already written with the oxidation state 3 and this is chloride Cl. Now the last point, the charge of the cation has to be balanced by the charge of the anion. So let us look at the oxidation state of cobalt. How much is this? Let us look at the oxidation state of the cobalt. Last point says what? Charge of the cation is balanced by the charge of the anion. So over here the oxidation state of cobalt is given to us is what? 3. That is already given to us. So 3 plus 0 plus 0 minus 1. How much is this? 3 minus 1, 2. So this will be a cross multiply. So when here it is coming 2, this becomes Cl2. Okay. Take the second example. Potassium tetrahydroxozincate 2. What kind of a compound it is? First we need to find out this. It is an anionic complex. So potassium means K we write. Then we put a bracket. Tetrahydroxo. Hydroxo has to be tetra with zincate. Zn. Then O. This is hydroxo. OH how much? 4 tetra. This is clear. Now zincate, the oxidation state is given to us as 2. So 2 minus 1 into 4, right? So this becomes what? 2 into minus 1 into 4 is minus 4. So this is equal to minus 2. So the charge over this entity is minus 2. So this will come where? The interchange of the charges will take place. Cation to anion and anion to cation. So since it is minus 2, 2 will come over here. So this is the formula of potassium tetrahydroxozincate 2. Let's take another example. This is the last example. Okay. Now you are going to practice some today on your own. Potassium trioxalato aluminate 3. First, recognize the kind of a complex. The complex is of what kind? X plus minus. Okay, because 8 is over here at the end and it is starting with a metal atom. Okay, so potassium means potassium. Trioxalato aluminate. So we write down aluminate and trioxalate. Tri means 3 times, oxalate is OX 3 times. Right? Now, what is the aluminate oxidation state given to us? 3. So 3, and what is the valency of oxalate? Minus 2. So this becomes, what is the charge over this that we need to find out? That charge will be given to the potassium. So I am calculating what? The charge over here. So oxidation 3 is given to you. 3, then this is plus minus 2 into how much? 3. Right? So this becomes 3 minus 6 is equal to 0. So this is equal to minus 3. This becomes 3. This is the formula. This minus 3 is the charge over this close square bracket, and therefore that charge is crossed to the crisscrossed to the metal. Okay, so with this I wind up today. Practice some writing down the formulas or writing down the IUPAC names. We shall come back tomorrow again working on some formulas, writing down and naming them. Thank you.